Today we are going to see the unit number 2, which is projection of solids. Previously we have seen 3 parts. One is 0 dimensional points. Second is 1 dimensional, that is projection of straight line. 2 dimensional, that is projection of lines, planes. Okay, in this unit we are going to see projection of solids. Okay, so here I am the first sum for the projection of solids.
So, hello everyone. While coming to projection of solids, we'll be discussing about 4 major shapes, which are hexagon, pentagon, cylinder, and cone. So, when it's coming to hexagon and pentagon, we have 2 types. One is prism and pyramid. And right now, we'll be discussing a question on hexagonal pyramid. And the question goes like: an hexagonal pyramid, a base side of 25 mm and axis 50 mm long, rests with one of its edges on HP, and its arc inclined at 30 degree to HP and parallel to DP, draw its projections. The first half of the question will be explained by her.
As per in given question, we are going to see the hexagonal pyramid. There are 2 types of hexagonal pyramid. The type 1 is where it stands in the corners, and type 2 is where it stands in the edge. And this is our 3D model of hexagonal pyramid. And this is our why it is looking like this. This is our first type, and this is standing in its corner. Corner is in this 3D model. This is our corner, and this is our edge. Today our given question is type 2. The hexagonal pyramid is in its edges. So it is in 25 millimeters. So let us draw using this pencil. After drawing, let us mark the origin. From the origin, when we are seeing the front view, we only see B, C, and G. We are not able to see A, F, and E. So we are expanding this, and this is our base. After that, as the 50 mm of height from the base, so we are drawing from the edges. This is our origin dash O dash. And after this is B dash and this is A dash. Why we are writing this A in dash? We only see front view for B, C, and D. So we are writing A, F, and D inside the bracket.
So, as discussed earlier, we have actually drawn a hexagon which will incline on its edges. So now, further moving on to the next half is that what we have done is we have the question has given that it is inclined for 30 degrees. So, as mentioned here, it is actually 90 over here. So, what we do basically is that we mark a point, and using protractor we take 60 degrees, so that here we have 90, and as we have already known, the total angle inside a triangle is actually 180. So we have 90 over here, and when it is 60 here, automatically we will be getting 30 here. So what we do is we take a protractor, mark 60 degree, and so we are actually measuring this length, that is B A dash and D E dash total length, and we are drawing a line over here, and then we are measuring B dash A dash length, and we are drawing it over B dash A dash as well as C dash F dash length, and we are actually drawing it here. So after that, what we do is we extend the lines, and we are drawing this at O dash. Then we are bringing down the lines here, and from here also we are bringing down the lines from F, E, and D. And then we get a structure here, we mark the points, and we are actually connecting the points so that we get the inclined hexagon, which is actually inclined at its edge. So then what we do is here we have a O dash, so we are bringing that line down here, and we are joining all the lines, and hence we got an hexagon which is inclined at its edge. So in a nutshell, it can be said that this is a question based on projection of solids, and we have discussed about hexagonal pyramid. So basically, we have 2 types when it comes to hexagon. One is inclined at its edge, the other one is inclined at the corner. So here we have discussed the question which is actually inclined at its corner, and which is how inclined at its edge, and the degree is also given, which is 30 degree. So after marking all that, we just extend this line, and when we are actually measuring it, we will be getting 30 degree, because it is according to the triangle rule. We know that the total angle inside the triangle is 180 degrees. So here we have 60 degree, and here we have 90. So 60 plus 90, which comes out to be 150. So the rest of the 30 degrees are actually given here. So that is how the question actually is. in the traditional method, what we actually do is that we'll be drawing the 30-degree first and we'll be measuring the whole length of that and we'll be drawing it here. But what we have done here is that initially we have measured 60 degree because as it's given already here it is 90 degrees. So when we are measuring 60 degree and extending this line, we will automatically get 30 degrees. It's actually an easier method to stick on rather than the traditional method. And